Open up your MTT, and we're going to be talking about real numbers today. And one of the shortcuts that you're going to be able to use is called reindeer in winter nap. If you use that order when determining what sets a number belongs in, it will make your work go much quicker and easier. So we're going to talk about real numbers. Real numbers can be divided into two major groups. The first group is rational, and the second group is irrational. Now, the most famous irrational number that we have is pi. Pi never repeats and never ends, and so that's the best definition of irrational, non-terminating and non-repeating. The second large group of real numbers that we have are called rational numbers. Now, rational numbers can be divided into three other groups, and we're going to take a look at those three other groups right now. Rational numbers are all numbers that either terminate or are repeating decimals. So the examples for rational numbers are 0 over 4, negative 0.9, 3.71, 8 to the negative 2, 1/8, negative 3, negative 8, negative 72, 0, 1, 4, 72 are all good examples of rational numbers. Now, within rational numbers, we have a group that are called integers. So the integers would be numbers like negative 3, negative 8, negative 72, 0, 1, 4, 72. Integers will not include fractions and will not include decimals. Within the integers is another group called whole numbers. When we're talking about whole numbers, you have only positive numbers starting with 0. Within that group is called a group of natural numbers, and that's all positive numbers, not including 0. All right, now let's start making some sets that can be examples of the different groups. If you're irrational, pi is the best example, but you could write 3.17268 ... and that would be another example of what an irrational number would look like. Rational numbers would be things like negative 3 1/5, negative 1/2, negative 0.34, negative 1, 0, the square root of 4, which is actually 2, 3, 4 1/3, 3 to the negative 2. Those are all examples of rational numbers. Integers are only whole numbers that are positive or negative. So you could start out with negative 3, negative 2, negative 1, 0, 1, 2, 3, ... Whole numbers will only be positive, and they start with 0. So that would be 0, 1, 2, 3, and continuing on. Natural numbers are whole numbers that are positive, but they don't include 0. So those are some more examples of the sets of rational numbers, which are integers, whole numbers, and natural, and also the set of irrational numbers, which are non-terminating and non-repeating. Now, this is where reindeer in winter nap. Okay, if we use that order, it's going to be much easier to determine what sets the numbers are in. We're going to look at number 5. First, we have to determine whether the number is irrational or rational. So we're going to say that it's rational. If it's rational, we're going to need to check to see if it's an integer. So it's rational. And yes, it's an integer. And because it's positive, it's a whole number. And it is a natural number. Negative 3 is rational or irrational? Well, it terminates, so it's rational. And then it's an integer. But it's not a whole number, and because it's not a whole number, it cannot be a natural number. So we stop. 0 is rational. It's an integer. It's a whole number, but it's not a natural number. -1/4 is rational, but it's not integer, and it's not a whole number, and it's not natural. So you see, once you hit the first no, you don't have to check the rest of the groups. Square root of 4 is actually the number 2. So number 2 is rational, it's an integer, it's a whole number, and it's a natural. Decimal 68 is irrational. And 3.678123, ongoing, that never repeats, is irrational. Now we're going to look at comparing rational numbers. The best way to compare rational numbers is to get it into the same format. So I'm going to take 3/10 and write it as 3/10. If I'm comparing fractions, I can do the cross product. This is 12, this is 10, which means 3/10 is greater than 1/4. Now I can still do the cross product on negative fractions, but I have to remember that the smaller answer is going to be closer to 0. So this is going to be -6, and this is going to be -4. Well, -4 is closer to 0, which means -1/2 is going to be larger. Okay, here I have 1 1/20 and 1 100. So I'm not going to worry about the ones because those are of equal value. All I need to do is look at 1/20. This is the tens place. This is the hundreds place. So this is 100th. Again, I'm going to do my cross product. So this is 100. And this is 20. So that means that... So when I multiply, I notice that I have 100 on this side, so that means 1/20 is going to be larger than 1.01. All right, now we're going to look at changing repeating decimals into fractions. To change a repeating decimal into fraction, we must use the n formula. So this is how the n formula works. The first thing that you're going to do is write n is equal to, and write out your repeating decimal with 5 digits. Now, we have one digit that's repeating, so we're going to multiply by 10. 10 is equal to 3.3333. Notice that when we multiply by 10, it moves the decimal one place to the right. That's what we want. We want one digit that is not repeating. Now we're going to subtract n, which is just simply subtracting off the repeating part of the decimal. That's going to leave us with 3 is equal to 9n. Divide by 9, divide by 9. N is equal to 1/3. All right, let's do the next one. N is equal to 0.121212. So now I have 2 digits that are repeating, so I'm going to have to multiply by 100. That moves the decimal 2 places. And now I have 2 digits that are not repeating. I'm going to subtract off an n, which is subtracting off the repeating digits, and that's going to give me 99n is equal to 12. Divide by 99, divide by 99, and n is going to equal 4/33. Now I don't have to worry about the 4, I only have to get the 8 into a fraction because the 4 is already a whole number. So n is equal to decimal 88888. I need to multiply by 10 to move the decimal one place to get a digit that's not repeating. And now I'm going to go ahead and subtract off just the repeating parts. So this is going to be 9n is equal to 8. Divide by 9, divide by 9, n is equal to 8/9. But remember that I had my 4, so this would be 4 8/9. We're going to do the same thing with 6 27 hundredths that is repeating. So n is equal to 0.272727. I'm going to multiply by 100 because I need to move the decimal 2 places. So 100n is equal to 27.2727. I'm going to subtract off just the repeating part. And so it's going to be 99n is equal to 27. Divide by 99, divide by 99. And I'm going to have n is equal to 3/11. But of course I had my 6 up here, so it's 6 and 3/11. Now for a decimal that's not repeating, it's pretty easy. 6/10 can be written as 6/10, which can be simplified to 3/5. 600ths can be written as 600ths, and that is going to simplify to 3/50. 6,000ths is written as 3/500ths. So you change the decimal based on the place value that it's sitting in. If it's in the first spot, then it's over a 10. If its last digit is in the second spot, then it's over 100. And if the last digit is in the third spot, then it's over 1,000.